Hi, so this is the experiment that you are doing this semester. So it's called
Centrifugal pump characteristics. We want to assess the pump performance when it's running in single connection. Then we want to assess the performance when we add a secondary pump connected in series.
in simple terms, we just gonna do this now. It's gonna be a single pump. So let this represent a single pump or a pump rather. Yep. And then we just wanna measure the output. We are interested in the results what we'll get here. So those outputs will help us to determine H versus Q graph. Similarly, we are going to connect the same pump with another pump now, but they'll be connected in series. So we are interested also just in the output as we connect these two pumps in series. So we are interested in the output, and it's gonna be H versus Q graph for these pumps as well. So by the end of the experiment, we are going to have two graphs. The graph that represents the single output, and then the graph that will represent the series output.
The apparatus consists of 1. Hydraulic bench, 2. Centrifugal pump for series connection, 3. Discharge valve. This is for adjusting our volumetric flow rate in the experiment. 4. Pressure gauge. 5. Centrifugal pump for single connection. 6. Pipes. We need pipes to connect the whole setup. 7. Jug. 8. Stopwatch. Also include 9. Water tank. 10. Power supply. The first instruction tells us to connect the setup, which it was already connected as you see in the video. The second instruction tells us to connect the pump either as single, series, or parallel. Cancel out the parallel connection. For today, we will run the experiment in single and series as I explained earlier in this video. However, in this video, we will be using series connection as a way to demonstrate for you. The next instruction says we must open the discharge valve fully, then start the pump. This student was opening the discharge valve fully, and this student was switching on both centrifugal pumps. The next instruction says we need to collect a certain volume of water using the jug, then record the time it took to reach that volume using the stopwatch.
Did you say stop at the right time? Yes. Okay, then we can take the break. That's fine.
Take the time right now.
2.4 seconds.
No, ready.
Stop.
For clarity's sake, each group was given its own volume. Even for you watching this video, you and your group will need to use the volume I will give you on the emails.
Then back to A. But now we have to change the pressure to 50. So somebody has to adjust by closing. Maybe 50 then we change. Nothing so far. Is it past? Okay, ngicela usi-adjust-ele, yeah.
Each group was given sets of pressures to run the experiment with. I will give you pressures to work with as
So
a
how
group
long
on
did it
email as
take
well. The
for 1
experiment
liter
started
to
at 0
fill
kilopascal, then
up?
adjusted to 50 kp, then adjusted to a higher pressure, and so on, while the
Oh, now we
volume
are at
remaining
0.05
constant
liters.
throughout.
Okay, let's go there. Okay. All right, back to here. I need you to correct one thing, which is this head. It's not actually head right now. It's still pressure in kilopascal. So, but once you do the calculation, you're gonna take it back to pressure head, which is something else different. It's supposed to be in meters. Pressure head is not in kilopascal. As you saw, the volume was constant throughout the experiment, and then they were just recording the time it took to fill up that certain volume of water per changing pressure. And they were doing that under series because that experiment was run in series. The last step is creating your Q and H values, obviously, because you are about to plot that graph. When you do your calculations, you just have to make sure that your flow rate Q is expressed in meter cubed per second. That means that the volume that is given in liters, you're going to have to convert that first to meter cubed, right? And then you're going to divide that volume after converting it by the time that we have here. Okay, that's how you'll get your Q points to formulate that graph that we are looking for. And then for H, we have the pressure. As I said, this is the part that represents pressure. You're gonna take these pressures and you're gonna divide by gamma. And then we know that, I don't know, they call it gamma or gamma, but I call it gamma. So gamma is given by density times 9.81. Oh, it's not doing that thing now. It's not focus. Oh, it's back to focus. So the density for water, because the one that we were using, it's from the tap, that's 1000. And then the G, it's 9.81, as you know. Then you can plot the graphs. That's it.